All right, this is 6.2, multiplying and dividing rational expressions, and this is page 4 of the notes. So hopefully you did the intro activity already, and if you have any questions from 6.1 or from the intro activity, please contact me. All right, so and the reason I say that is because if you don't have a firm understanding of 6.1, this will be pretty confusing, I bet. All right, so our goal now, as you can see, there's kind of a practical application up here. Working with recipes, we have to multiply a lot if we want to half the recipe or double the recipe. These numbers help us expand or decrease the amounts, right? Proportionally. So that's the point of multiplying. So if we have to multiply and there's a variable in there for some reason, we're going to need these skills. So the first thing that you've got to remember is we can't simplify anything. We could multiply, but it would just kind of get more messy. So if you remember when you multiply fractions, you just multiply straight across. But as you can see, that would get really messy, and it wouldn't help us in our end goal of multiplying and simplifying. So remember, we need to turn it into a multiplication problem. I mean, it already is, but in each numerator and denominator, we need to do that by factoring. Okay, so be neat, because there's going to be a lot of factors flowing around, so try to be very, very neat and very, very organized. So when we factor, you got to remember if your a is 1, there is a shortcut. So the shortcut is if your a is 1, there's no other option at the beginning of the factor, so it's going to be x times x. And then there's no other option for the end. It has to multiply to give us negative 10, so that's c value, but also add to give us 3. So I'm going to think of the numbers that multiply to give me 10, which are 1 and 10, 2 and 5. So then I think 5 times negative 2 gives me negative 10, but also adds to give me 3. So I'm going to have x plus 5 and x minus 2. Okay, I'm going to cross that off because it's now factored, and I don't need that anymore. And then the next denominator, I'm going to pull out a 7, so just greatest common factor right there. And I have 7 times x minus 3 when I factor that one out. There's nothing I can do to the numerators, so I'm done with my factoring step. Now, to avoid harder times at the end, we're going to find our excluded values now. Find excluded values by, if you remember, an excluded value is any potential number that could go in for the variable x and cause issues. And in this case, because we're working with fractions, we can never divide by 0. You just can't. So anything that would cause the denominator to be 0 is an issue. So take a look here. When we're multiplying fractions, we're just multiplying straight across. So I can technically just put a multiplication sign here, and they're all one fraction now, and that would be the process. So hopefully you remembered that up there. For example, as you're multiplying 1/2 times 1/6, you just multiplied straight across. You got 1 times 1 and 2 times 6. So notice I'm just kind of speeding up that process down here. Okay? All right. So again, we're on this excluded values. We cannot let the denominator be 0. So we've got to find those by setting each denominator factor equal to 0. Okay. So x plus 5 cannot become 0, right? Because then when we multiply, it'd make the whole thing 0. So x cannot be negative 5. And notice, I mean, you don't have to literally set each one equal to 0 if you can look at it and see. So if I can look and see what will make x minus 2 0, okay, I can pull that out and I don't need to set it equal to it. But, I mean, you can if you want to. It cannot be that. Okay, so it can't be 2. Same thing here. X minus 3 cannot become 0. which means x cannot be 3 ever, or it will become 0. And then the 7, there's no variable, so we don't have to do anything with that 7, because there's no way it could become 0, right? There's nothing influencing it. There's no relationship with any variables, so we're good. We found all our excluded values, so we're going to hold on to those. But remember, we're not done here, okay? So we factored, we found our excluded values. Now we're going to cross off, I'm going to call them our matches. So if you remember, anything divided by itself will go to 1, and then as we multiply, it'll keep the rest of the problem the same. So I'm going to look very closely and notice that I can cross off this x plus 5. All right. And then I'm going to remember 14 is 2 times 7, so I can cross off this 7. And if this is not neat for you, I could have rewritten it, and I'll do that on a practice problem if this isn't neat. But those are all the matches. So now as we look at the numerator, I'm left with a 2, an x, and nothing else. So I have a 2 and an x there. And then in my denominator, I still have this x minus 2 and this x minus 3. All right, so it's simplified form, but we are going to want to multiply that denominator. So we want to combine, and I'm going to call it the leftovers, whatever you want to call it, though. So 2x, nothing happening there. And then I'm going to just quickly do some double distribution. If you do box method, that's fine. But I'm going to get x squared minus 3x minus 2x plus 6. Negative times negative is positive. So I have x squared minus 5x. And then I'm going to have plus 6 there. So that is my reduced multiplied fraction. But x can never be negative 5, 2, or 3. Okay. All right, so that is how you multiply. So go ahead and flip the page, and we're going to go down and do a few examples. If you don't need these examples, if you're like, got it, multiplication, easy, in the bag, then you can fast forward until you see me go up to the division part, okay? But if you want to stick around and do this, you can. So I suggest you pause it, try these, and then watch this and make sure that you did it correctly, okay? All right, so I always like to factor first. So I'm going to do that. Factor everything I can. A is 1, so I don't have to do the full-on process where I break up B. All right, so I'm just thinking what multiplies to give me 2 but adds to give me 3. Got it. Okay. And then these are all being multiplied together. So I am good to go through the normal simplification process now. So multiplying process is not difficult, right? Because you're just multiplying straight across. So it's just kind of one teeny extra step is that you got to remember that these two things are combining numerator to numerator, denominator to denominator. All right, so I got to make sure that this never becomes 0 in the denominator. So I'm going to take a look at these. X plus 2 can never become 0, so x can never be negative 2. And then this x can never become 0, so negative 2 and 0 are out. Okay? All right, so now I'm going to cross off any matching pairs. X plus 2 divided by x plus 2 goes to 1. X divided by x goes to 1. So I'm left with 3 times x plus 1. There's nothing else in the denominator. There's the 3, there's the x plus 1, everything else was crossed off. So now I'm going to multiply that to simplify it some more. 3x plus 3, where x cannot be negative 2 or 0. Okay. All right, let's do b real quick. Okay, so I love to factor first. This right here is in the numerator. So I'm going to just kind of extend this line basically, but I don't want to cross that off so I can't read it. But just kind of extending that. And this I cannot factor, right? 2 and 5 have nothing in common, so that's just going to hang out there. I'm going to think what multiplies to give me negative 6 but adds to give me 1. 6 and negative 1, right? So x plus 6, x minus 1. And I'm going to draw that and kind of cross that off. Okay. All right. And now I look at the denominator. I can pull a 3 out. And I'm left with x minus... Oh gosh. Sorry. Bad factoring. Woohoo. Let's start over on that real quick. It has to multiply to give me negative 6, add to give me 1. What I had, 6 minus 1, would have given me 5, right? So I need x plus 3 and x minus 2. That's a little bit better. So hopefully you already saw that and you're like, what the heck is she doing? All right, we pull out a 3. We're left with x minus 2, and I don't need that anymore. So here's my big fraction, right? I have those 3 factors in the top and the 2 factors in the denominator. So I want to make sure the denominator never becomes 0. And if I do 2 minus 2, I'm going to get 0. So x can never be 2. The 3 is not an issue, right? 3 can never become 0. So I don't need to do anything with that. There's only one number that would make that 0. All right, go ahead and cross off your like terms there. X minus 2 divided by x minus 2 is 1. 1 times anything makes the rest of the problem stay the same. So I have 2x plus 5 times x plus 3 all over 3. Okay, now I'm going to multiply that. So I'm going to get 2x squared plus 6x, boom, plus 5x plus 15 divided by 3. I have some like terms in the middle I can combine. So 2x squared plus 11x plus 15 divided by 3, where x can never be 2. And I'm done. Sorry for the factoring mishap right there. All right, so that's multiplication. We're going to move on to the last topic. Things to remember when dividing rational expressions. Okay, so very similar. We're going to factor everything. Okay, so that's always going to be your first step, I suggest. If you find a way that's quicker for you, do it, of course, though. All right, so be neat. Remember to be neat. This is a difference of squares, so that's easy. X minus 5, x plus 5. All right, and moving down below, GCF factoring right there. So I'm going to pull out the 4 and be left with x plus 7, right? And then the next one, yay, my a is 1, so I just got to think what multiplies to give me 14, which is 1 times 14, 2 times 7. But as to give me 9, it's going to be the 2 and the 7, right? Since my a is 1, I can do my quick factoring. X plus 2, x plus 7. Okay, now notice my numerator, denominator. I'm just trying to be neat with all that, okay? All right, so I factored. The reason I factor is so that it's easy to find my excluded values. That's why I factored first and didn't even worry about dividing. So we have to find those excluded values. We're going to have to set each factor in the denominator. We don't care about the numerator. If the numerator becomes 0, great, it's 0, right? But if the denominator becomes 0, there's an error. You can't divide by 0. So set each factor in the denominator. Technically there's 2, right? Equal to 0. All right, so let's take a look here. 4, never going to become 0. X cannot be negative 7. What would make this guy 0? Negative 2, right? And then negative 7 again, I don't have to rewrite it. Okay, so I found the 2 values that would cause issues. Okay, 3. Take care of division. How the heck do you do that, right? So remember, when you're dividing, it's the same as multiplying by the reciprocal. What's the reciprocal? It's that fraction flipped, right? Okay, so I'm going to rewrite, so number 3, this is step 3 right here. I'm going to rewrite the first one, x minus 5, x plus 5, and 4 times x plus 7. And I'm going to multiply by the reciprocal. So anything in the denominator of that second fraction will go to the numerator, and anything in the numerator will go to the denominator, right? So remember, hopefully you kind of looked at it up here or thought about it maybe when you were doing this little situation. But if I have 5 times 1/2, or 5 divided by 1/2, it's the same as doing 5 times 2 over 1, which is 2, so it's 10. Okay, just kind of a side note, multiplying by the reciprocal. Or if I had 5 halves and I had divided by 3 halves, that'd be the same as 5 halves times 2/3. So just showing you can multiply by the reciprocal, the first part stays the same. Okay, so that's what we just did. So now, we have an issue, right? We just created a new denominator. So you've got to find any new excluded values. So don't forget this step. Okay, so as we look over here, we already have this one, we already did that on the left, but we don't have this one on the right, so x cannot be 5. So I'm going to just box those in real quick. Okay, and then 5, you're going to cross off matches. Remember, matches are the things that are going to cancel out and become 1. So x minus 5 divided by x minus 5, because technically this is all together, would go to 1, and then the rest of the problem would stay the same. X plus 7, see ya, right? And then the last step, we are going to combine our leftovers. Now these are in quotes because they're not the true terminology, of course. So we have x plus 5 times x plus 2 over, so that was left, that 4 is left, okay, which will become x squared plus 7x plus 10. I already multiplied that a little bit earlier, but you can double check it if you don't believe me, where x cannot be 5, -7, or -2. All right, that's it. So I'll do one more example, but if you're feeling great, pause this and go to the homework. Maybe I'll do 2 more examples. We'll see. But yeah, for sure pause if you're done and go do the homework. Okay, or quiz. All right, so dividing, first step, factor. Okay, done with that guy. The only thing I can pull out of that is 2, right? 6 and 10, the only like term that I have is 2, which would leave me with 3x minus 5. Done with that. All right, yay, my a is 1, so that means I'm going to have an x. Got to think what multiplies give me 8, adds give me 6, which is 4 and 2. All right, done with that guy. And then here I'm going to pull out a 3. 3 out of 9 would leave me with 3. 3 out of 15 would leave me with 5. Okay, now I'm going to set each, I got to find my excluded values, so I'm going to set each, well, they're the exact same thing. So I'm going to make sure that this, because it's in the denominator, never becomes 0. So I'm going to add 5, divide by 3, x can never be 5/3. Okay. And then the 2 and the 3, there's no way they can ever become 0, so they're not an issue. Don't forget about this. All right. So now we're going to change this guy because division's kind of an issue, so we'll multiply by the reciprocal. So I'm going to take this first part, leave it the same. Now I could have simplified the 4 and the 2 right there, like I could have if I didn't want to rewrite it, but I'm gonna wait till the end. Okay, so multiplying by the reciprocal is what we need to do. Okay, all right, so I flipped those, I'm good, I'm done with that. Great. But we have an issue, right? We just created a new denominator in this problem. So that will cause some issues. So x can never be -4 or -2. Okay? Alright, so there are now 3 things x can never be. We gotta remember all of them in the end. So, see ya, x plus 2 divided by x plus 2 is 1. 3x minus 5 divided by 3x minus 5 is donezo. And then 4 divided by 2, that's 2 times 2, right? So I'm left with a 2. So in the numerator I have 2 times 3, which is 6. And then in the denominator I have x plus 4, where x can never be -4, -2, or 5/3. Okay. Alright, if you'd like to stick around for another one, I'll do E, but if you're done, go to the homework. Okay, so first step, I'm going to factor. As I look at this numerator here, it looks like GCF. 3 and 12 are both divisible by 3. X squared and x are both divisible by x. So then I'm going to have x minus 4. Cross that off so it doesn't get crazy. Now notice this is technically, don't forget you're dividing. But this is technically in the numerator, so I'm just going to kind of draw that, but not forget that I'm dividing. So I got to think what multiplies to give me -4, adds to give me 3. My a is 1, so that's going to be pretty nice there. Okay, so I'm going to have x minus 4, x plus 1. Okay, I'm factored. I'm looking good, and then I got to look at my denominators. Well, I only have that 5x, so right there, x can never be 0. Okay? Alright, so now I've got to take care of this division, which I crossed off. You cannot divide really easy. It's just, I don't know, maybe you can. But I think it's way easier to multiply by the reciprocal. So, rewrite the first one, leaving it in factored form so that I can, and again, you could have crossed off those x's and not rewritten them. I'm going to multiply by the reciprocal. There's always a 1 in the denominator if you don't see one. Alright, now we've got to check this guy, for the excluded values because we created a new denominator, right? So x can never be 4 or -1. Those would both make it 0. Okay, so don't forget I have this guy over here and now these two. Okay, now just notice that we are ready to go, ready to roll. X minus 4 divided by x minus 4, x divided by x. My leftovers in the numerator are 3 times 1, which is 3. And then 5 times x plus 1, which is 3 over 5x plus 5, where x can never be -1, 0, or 4. Done and done. Alright, so let me know if you have any questions, worked on the homework. Good luck.